Hey everyone, it's Miss Gubrud. We're back at the Unit 2, Lesson 3. This is the second part, so it's Unit 3B. And today's lesson is going to focus on not only helping us understand parallelograms, the base and the height, what the formula is, and identifying rhombi, but we're also going to focus on problem-solving strategies because there's lots and lots of problems here that need strategies to solve them. The strategy we're going to focus on, drawing a picture. If you had math with me last year, you know that's always the first thing that I sit down and help kids do. After they reread the problem, we try to sketch out what's going on, and it works so well. I really hope you try it. Okay, let's get to some vocabulary today. So let's just dive right in. Oh, whoa, weird. Okay, my computer's doing something weird there. Let's see if it lets me present. There we go. Okay, parallelograms. We talked about them yesterday or last week. Parallelograms, it's a quadrilateral, so it's a four-sided polygon that has two sets of parallel sides. If you extend the lines that are on the sides there, if you just extend them with your ruler, they'll go on forever and ever, and they'll never cross. They always stay the same distance apart, kind of like railroad tracks, crossing railroad tracks. Here's a pro tip. You may have thought about this last week. A rectangle is a special kind of parallelogram. So a rectangle is always a parallelogram because it has four sides and there's two sets of parallel sides. But a rectangle also has four 90-degree corners. So that's why it's a special kind of a parallelogram. And that's why we call it a rectangle. Not all parallelograms have 90-degree corners. All right, the height of a parallelogram. I tell you what, the base of the parallelogram is pretty easy. Most people have no trouble with that one. But the height of the parallelogram can be extra tricky for kids sometimes. Don't let this happen to you. The height of the parallelogram, first of all, it's perpendicular to the base. So take a look at my picture there, line CD, and it's crossing line AB. And notice that it's crossing at a 90-degree angle. It's crossing straight up and down and making two square corners. Perpendicular means that the line makes a right angle when it crosses another line, and the two lines cross at 90 degrees to each other. So take a look at that. One of the tips to find the height of a parallelogram is it has to be a perpendicular line to the base. Now, let's think about it this way, because that's tricky for kids. So let's think about it this way. When you go to the doctor's office for a checkup, they always start by measuring how tall you are, right? You go in there, they weigh you, they maybe check your eyes, and they figure out how tall you are. But here's my question for you. Do they measure you from the bottom of your feet to the top of their head? Or do they let you lean towards the wall? Have your feet way away and lean towards the wall? Let's try it both ways. All right, this is a you try it at home activity. We're learning about how to figure out the height of a parallelogram, and we're going to do it by figuring out our height. Now, you've heard that when we go to the doctor, and I'm sure you've had that experience, go to the doctor, one of the very first things they do is weigh you and measure you, how tall you are to see how tall you've grown. Now, how do they do that? Well, typically, at least when I've gone to the doctor, they have you stand up next to a wall, and they have like a little thing that kind of comes down from the wall, and it's sort of like lands right on the top of your head. And then they look straight across and they mark how tall you are. So I just marked how tall I am there. Now, I'm about 5'6", so we'll say that line is 5 feet 6 inches tall. And now you can see I measured myself from my feet up to the top of my head. I can't turn the computer down to show you my feet right now, but you can see me walking back, and I measured from the feet to the top of my head. Now, what would happen if instead of going from the very bottom to the very top, what if I instead leaned toward the wall? How tall would I be if I leaned toward the wall? If I came out like this far, I stood here instead of way back by the wall. What if I came out further like this, and then I leaned towards the wall? And then I marked myself. Would I be taller or would I be shorter? Now, I personally wouldn't change at all, but would the distance that I'm able to go be bigger or smaller? Well, let's think about that a minute. Okay, I'm going to try it. Here I am. So I'm going to start right here. This is what you're going to do too, incidentally. And I'm going to lean. Maybe I chose a little too far. I'm going to lean towards the wall. Okay, here I go. I'm leaning. Now I'm trying to measure myself. With my head. Oh, okay. There it was. I look a lot shorter, don't I? But why do I look shorter? Because if I was trying to stand here and lean towards my actual thing, I can't get there. My head's not that far. Look what happens. I'm going to lean, but is my head anywhere close to there? No, it was a long ways away. It's further if you lean than if you just stand straight up and down. Straight up and down. Here I am. I can measure right there. 5 feet 6 inches. But if I'm leaning, my head doesn't even get anywhere close to that. In fact, it doesn't even touch the board. Look at that. That's what I want you to try. I want you to try to see if after you measure yourself, and some people do this in their house already. Some people have like a little how I've grown kind of chart. Do this, measure yourself, then take a couple big steps away and see if you can get your head onto that line. Pause and try that now. Can't do it, can you? It's because it's further. A line that's diagonal that connects the bottom and top is further, it's longer distance than if you measure straight up and down. Why am I having you do this aside from it's just kind of fun? Well, because the height of a parallelogram really tricks kids, and I don't want you to be tricked. So, there's a parallelogram. Oh, you know what? I might have to pause this and bring you in closer. All right, there's our parallelogram. It's easy to measure the base. The base we know super easy. The base is what it sits on. That's that distance right there. Easy peasy lemon squeezy. It's the height that tricks kids. So here's the question. When I tried to measure leaning towards the wall, or when I tried to measure going straight up and down, which one was my actual height? Straight up and down. When I was measuring here, what I was really doing is standing right in that corner. Now, if I go to the doctor, they want to measure me straight up and down. What would happen if they let me lean forward to try to get to the wall? Would I be able to? Would that distance be my real height? If I stood here and leaned forward and said, look in here, look how tall I am. I'm right here. If I keep going up, that's how tall I am. Would that be true? That's not true. That's not an accurate representation of how tall something is from bottom to top. So this line is a side, and you definitely need it if you're counting the perimeter. If you're counting how far around the outside edge, you need that number. But don't let that trick you. Sometimes kids think this is the height, but we don't measure height like that. We measure height from the bottom to the top, and we have to go straight up. If you went to the doctor and tried to say, ooh, I want to pretend I'm a little taller, so what I'm going to do is I'm going to stand further away, and then I'm going to lean. In fact, I'm going to put my arms up like this. Like I'll say, oh, you know what? We've been learning about parallelograms in math, so I'd like to just do kind of a parallelogram. All right, hold on. I'm going to back up a little bit. You say, okay, here's my plan. I want to be a little taller. So when they tell me to measure my height, I'm going to stand way back here. Then I'm going to have my marker ready. I'm going to lean forward with my arms up like this. I'm going to lean forward Ooh. And I'm going to say, look at me. This right here, that is as tall as I am. Is your doctor going to be tricked? Your doctor's going to say, that's messed up. Who's your math teacher? No, we don't measure like that. We don't measure at an angle to see how tall something is. We have to go from the bottom straight up to the top. We had to put this line in. It's not already there. Sometimes it is, but if it's not there, don't get tricked and say, oh, I see it. I see it's right. No. It has to go bottom to top. You could even put the line right there. You could put it right here. You could put it right there. I'm still 5'6". No matter where I go all along, I don't get any taller or shorter if I go side to side. So you can put the line side to side. You could even do this. You could even go out there and go straight up that way. The only thing you can't do is go at an angle. You can't measure at an angle. Try this at home. All right, we're back. It doesn't work both ways, does it? They won't let you lean towards the wall because they would not get an accurate depiction of how tall you are. If you stand straight up, bottom to top, you are one height. But if they let you lean like I did and reach way out to see how far you could reach, nah, that would give you the wrong amount. In fact, that line is too long. The line going diagonally from the bottom to the top is too long. That's not the height. The height goes straight up and down. So thanks for trying that. We're back now. We've got one more piece of vocabulary to take a peek at. Now, let me see if I can present. Let's take a look at this. Rhombus. It's another vocabulary word, or the plural, rhombi. So if it's just one, we call it a rhombus. If it's more than one, we call them rhombi. A rhombus is a special kind of parallelogram that has all four equal sides. So it's a parallelogram. It has two sets of parallel sides. It's kind of like a square in that it has all four equal sides. And here's a pro tip. A square actually is also a rhombus. So you could call a square a rhombus because it is a parallelogram that has four equal sides. Kind of think of a rhombus like this. Think of it like a square that someone sat on and squished flatter. The length of the sides didn't change, but the angles changed. So here's your square. There it is. Now we're going to tip it this way. Don't let that trick you. It's still a square. It doesn't change into a diamond just because you turned it sideways. It was a square. Now it's a diamond. No, it's still a square. And then someone sat on it. Squish. It didn't change the length of the sides. They stayed the same. It did change the angles. So a rhombus is a parallelogram, a special kind, that has all four sides the same length. All right, let's dive into today's work. So please pause and go grab your math book. All right, I'm on page 67, so please join me on page 67. Here we are. It says a rhombus is a parallelogram with all the sides the same length. We know that. Place a check mark next to each rhombus. So take just a quick look and say, which of these ones look like they have sides all the same length? Now, we for sure can look at number 10 and say, no, that doesn't even look like it. And we see 7 is on one side and we see 4. No, that's not it. So we take a look at this one and we see 4. And then this, don't let this trick you. That's the side right there of the parallelogram. And it says it's 5. So that's not a rhombus either. So go through and put a check mark on the ones that are rhombi. So go ahead and do that. Then let's take a look at number 9. So number 9 has one side is 6 centimeters. The other side is 6 centimeters. Oh, both sides are 6 centimeters. Now, we know that if in a parallelogram, the two sides that are opposite to each other are equal, but you also know that what they should have done, and I wish they had done this, but they didn't, so we need to do it instead. What they should have done is they should have put that little crosshatch and crosshatch and crosshatch and crosshatch. That would have told us all four sides are the same. Look at number 10. We know those two aren't. So we're going to put one crosshatch across the 7, and then up here, that's the opposite side there. That's the same length. But what are we going to do for the other side? You're remembering it's a different size. We got to put 2 crosshatches. So there's 2 crosshatches and 2 crosshatches. So that's going to really help you identify which ones are the rhombi, because they only use the same symbol. They only use one crosshatch because all the sides are the same. Now, the other thing that might trick kids as they look, they might say, wait a minute, we have this number like in the middle of the shape. What does that mean? Well, first of all, don't let it trick you. You might need to rotate this shape. So literally, you might need to do this. You can take your book and do it. I can't. I wish I could. But you just saw me taking a screenshot. I'm going to insert that and turn it. All right, look what I did. You can just turn your book to the side. But if I do that with the computer, that's messed up. You'd be like, whoa, my teacher's messed up here. No, we can't do that. So I screenshotted it and I turned it around and put it in here. Now it looks more like what we're used to seeing. We see a base, and now we see, oh, I see that dotted line. That's the height. So let's find the base. There's the base. And we know it matches with this one. So even though it's not labeled, since it matches that one, we know the base is 6 centimeters. That's really hard to see, isn't it? Let's use orange instead. There's the base, and it is 6 centimeters. Now, let's take a look. This dotted line, remember what we just talked about. That dotted line is the height. It has to be perpendicular, which means it makes 90-degree angles. It's got to be perpendicular from the base. That's the height. And it also can't be out on the side. It's got to go straight up. So there it is. That's the height. So we see the height is 5 centimeters. Now, we know a parallelograms, the formula for parallelogram for finding the area is base times height. Same as a rectangle, because we could take this chunk off, that whole chunk right there, we could cut it right off, and we could move it right over here and draw it right back on. There it is. And now we've changed it into a rectangle. We've gotten rid of that part, and we've changed it into a rectangle. So because we can do that with a parallelogram, we can cut one part off and move it over onto the other side, just slide it right over. We didn't change the size at all. We just moved one part to the other, stayed the same size. We can use base times height. So our area, there's area, equals base times, remember a little dot means times, height. So our base is 6, our height is 5. That means our area is 30. And don't just leave it at 30. Remember, we're talking about 6 centimeters going one way, 5 centimeters going the other way, but it's actually how much stuff is inside, how many little squares are covered. So it has to be 30 centimeters, and not just distance, 30 square centimeters, because it's how many little squares are covered. All right, we still have to find the perimeter. Now, don't get tricked with the height on the perimeter, because the perimeter person goes all around the outside, skateboarding, flying, rollerblading, walking, running. We had a lot of different ways that our perimeter people were walking around the outside, but they get to walk around the outside. So here's our perimeter person. There they are. And in this case, they've got their cape flying out behind them. Whoa, well, you can't really see that cape. There it is. There's their cape flying out behind them. So they're going to walk along there, collect 6. They're going to walk along there. Well, we know that that's another 6. They're going to walk along there. That's another 6. They're going to walk along there. That's another 6. Did they use the 5? No, and they shouldn't, because the 5 isn't on the perimeter. So it's 6. Collected 6 more, collected 6 more, collected 6 more, 6 plus 6 plus 6 plus 6. The perimeter is 24. Now it's 24 centimeters, but is it square centimeters? It's not, because it's not how much surface area, it's not how much stuff could fit in the inside, it's how far around. If you think of holding a tape measure and just measuring out and walking all the way around, it's just straight distance. So that's just 24 centimeters, not square centimeters. All right, let's take one more look at one that's a little tricky. Let's look at number 11. 11 gets tricky because look where they're measuring the height. Can you figure it out? Which line is showing the height? It's the line that's perpendicular to the base. There's the base. Now, they extended the base. They didn't actually change how much they want. They still know that it starts here and it stops here. That's where the base is. But they extended the line out so they could go straight up to the top. So what's the height? It's the 3. Where's the base? It's still the 4. Don't let that part trick you. They're not saying that's part of the base. They're just making that line straight so we could, remember how I moved all along the board? No matter where I moved, I was the same height. That's what they're doing. They could take this line right here and they could move it there or here or here. They could put it anywhere because it's still, how far is it from the bottom of the shape to the top of the shape? And we could extend that as far to the left and to the right as we want, and it won't change the height of the shape. Just like me moving along the board back and forth. I didn't change height. I didn't grow or shrink. I just moved side to side. So in this case, here's the base. It's 4. Here's the height. It's 3. And then don't get tricked. That 5, that is showing the length of this side. That side is 5 centimeters. Notice how 5 is bigger than 3. Remember how we said if you measure yourself at going at an angle, it's going to give you the wrong measurement. It's bigger, takes a more distance to cover going sideways than it does going just straight up and down. So that 5, the side, length of the side is bigger. It's not the height. All right. Good luck on all of those problems. All right. This is the part where you really have to draw a picture to help you. They don't give us a picture. I am now on to page 68, and the first one says June is designing a pattern for a rug. She uses rhombi with triangles in between them. Each rhombi will have 10-inch sides and 9 inches of height. Okay. In order to picture that in our mind, we should be making a mental picture when we read. That's always a good strategy. Miss Hubacher probably tells you that a lot, that you should have those movies going in your mind of what you read. But let's just pause and draw a picture. It says show your work, so let's show our work. So there's a rhombi, a rhombus. Remember, the sides are the same length, but it's kind of been sat on a little bit. Now, that's not perfect, but we're going to pretend the sides are the same length and it's been sat on a little bit. Okay, so I'm going to also put my little cross hatches to show that all those lengths are the same size. There it is. Now, each rhombus will have 10-inch sides, so we could write 10 on every single side if we wanted to. We don't necessarily have to because we put those little cross hatches in and we know that every side is 10, but that's okay. We can write it in. It's always good practice. And a 10-inch height. Now you might say, well, is the height from down here to up here? No, remember the height has to be a perpendicular line from the base up to the top. So you could tip your book sideways. In fact, I encourage you to tip your book sideways. When you tip your book sideways, you're going to find out that, I'm going to grab a different color here. You're going to find out that the height goes from the bottom straight up to the top, like that. So the height is, we would measure it kind of inside the rhombus. The height is 9 inches. All right. What is the area of 4 rhombuses? Now, a rhombus is a parallelogram. We know area equals base times height on a rectangle as well as on a parallelogram. So we have the base. It gave it to us. told us the base was 10, told us the height is 9. So 10 times 9, we know, is 90. Are we done? Is that the answer? We forgot. We got to go back and read. What is the area of 4? So we need not one of these shapes, but 4 of them. You could draw that if that's helpful for you. But I know that 90, 4 90s, is 360. So I know I need 4 of them. So I'm going to say 90 times 4 is 360. Now, 360 what? 360 cupcakes? 360 dry erase markers? 360 globes? Well, I have 3 in my room. That's not quite 360. 360 inches, because we're measuring in inches, and not just inches, because remember, it's how much surface, how many squares could it cover, so it's square inches, 360 square inches. Let's try the second one. Again, drawing a picture. Please, please, please draw a picture on every single one. Use that strategy of drawing a picture, drawing a picture, drawing a picture. Deirdre is making a design for the bottom of a dress using rhombi cut from different colored fabric. Each rhombus has a base of 3 and a height of 2. So here we go. Remember, it is kind of like a squished out square. So the lengths are the same, but the angles are a little bit different. It's not quite 90. There it is. Okay. So a squished out square. There it is. All right. Each rhombus has a base of 3. There we go. I'm going to go ahead and put in my crosshatches because I want to remind myself all of these sides are the same. If one base is 3, all of the sides are 3. The height, again, you can turn your paper so that you can draw the height perpendicular to one of the bases. Maybe you just drew it like that, but if you didn't, do it what I'm doing. Turn your paper and draw the height from one of the bases to the other one. It has to be perpendicular. There we go. So the height is 2. You got it. Now, each rhombus has a base of 3 inches and a height of 2 inches. How much blue fabric does she need for 12 rhombi? That's a lot. Okay. We can figure out 1, but it's not just one answer. Once we figure it out, we have to make 12 of those because her dress has 12 of them. So keep going. Keep drawing a picture. Keep turning it if you need to. Turning your book if you need to. Don't feel silly about it. Don't be weirded out by it. Sometimes shapes are easier to see in a certain orientation, and it's absolutely okay. Good luck. See you next time.